Hi, okay, today I'm going to start with demo 1 part 3. Okay, so before watching this video, make sure you already visit our part 1 and part 2. So go to YouTube, search Silver Bay, you will get our channel. Okay, so go to playlist. Okay, so section here, there's a sequence you should view before viewing our current part 3. First, you have watched this quick start, and the second is 51 demo 1 part 1 and 52 demo 1 part 2. Okay, so after finish all these 3 tutorials, you continue with our current video. All right, it's demo 1 part 3. All right, so close this one. So again, I do. You can download our. You can download our working sheet at the Silver Bay. You can download our video. Okay, like part 1. You can download our working sheet under the description here to get the free online trial user manual. To work with this tutorial video, you can download this working sheet. Okay, here. Okay, it take a while to download. Take a while. Okay. Alright, so that's the working sheet we use for this video. Okay, you can download it from description of this video. Alright, so now today we are going to start with part 3. Let's start with connection 442. Okay, 442. Okay, it's this one, which corresponding to plan view. Okay, this working sheet here, come here, corresponding to 305 here. Okay, so we will start with 2 shear connection. One is the connection number is 442. All right, so 442. So first is 236 connect to the column strong axis. The column size is 250 by 58. Okay, another one is the beam 250 73 connect to width axis of column is 250 by 58. All right, so we are going to start with shear connection and 442 strong axis first, which is this one. Okay, 236 shear connection to W 250 by 58. Okay, we will start with this one. All right, so I'll move this one to another screen. So okay, so shear connection, and the column size section. The column size is Canadian shape, 250 by 58, 250 by 58. The beam size, okay, the beam size is Canadian section is 236, W 236. Okay, 236. Here you go. And okay, they are okay. Here you go. Again, so there are 2 rows of bolt with 3.5 inch. Okay, 2 inch from the top. Okay. All right. So oh no, I should not move this out. I should move this out and keep this one here. So 2 rows of bolt, pin to column and plate. you see this one, the end plate extend to weld to flange. Okay, extend to weld to the flange by 1/4 weld. So I have to choose extend to beam flange here, and I have the 2 rows. Okay, and 3.5 inch. So here's 3 inch, 3.5 inch, 3.5, and the distance here is 2 inch. Okay, so I think here is 2 inch, right? So I think no, here is 2 inch. I think we go for 2.5. Okay, that one 2.7. Let's keep to the same then. Okay, so just weld it, and the gauge is 4 inch. Okay, so gauge is okay, here let's say it's 3.5. Okay, and the plate thickness is 15.8. I believe it's 5/8. Okay, 3.5 gauge. All right, so 3.5 gauge, 3.5, and gauge 3.5, 6.258, and here is 1/4, 1/4. Everything is 1/4, right? 1/4. So everything is 1/4. Everything is 1/4. Update. Okay, so and 5/8. Okay, 1/4, 1/4. The force tensile is shear tensile is 150, and the shear force is 128 kilonewton. Okay, 128. All right, so 128 unit conversions, force 128, 128, no, 128 is 28.8 kips. 28 point design low. What's that? 28.8 kips. It's 29 here. Yeah, correct. So 28.8. The v-axis is 0. Okay, the tensile is 150 kilonewton. 150 kilonewton. 150. It's 33.8. 33.8 minus. Okay, minus means indicate tensile, positive means compressions. Okay, so it's done. All right, so we have shear force 28.8 kips and tensile of 150 kilonewton, which is 33.8 kips. So here's half of the section shear capacity, okay, corresponding to this one. So we get the excuse me, we get the ratio of 0.1. So go to here, the result here, sketch here, sketch here. All right, so we have this one. So we finish this one, and now we go to that's strong axis 236 to 250 by 58 column strong axis. Now we go to the v-axis 250 by 73 to v-axis of 250 by 58. It's this one. This one, all right. This one to a v-axis, and the section BB. Where's section BB? Section BB is this one. All right, so move this out and minimize this one. Now column size is the same, but it's been to column web, and the section of being changed to 250 by change to this one. Okay, that one 10 to v-axis, still the same size of column. All right, so 250 by 73. Okay, so and the now is 2 rows, 3.5, no change. Everything is no change. Okay, 2 rows. Oh no, there's one more rows below, but I don't have one side. I can extend both. So there are 3 rows here. I would say, okay, I tell you what, I don't have the options one side of extension. I can only extend both sides. All right. So I'm thinking, can we try 3 rows like this? Yeah. And we go to 3-inch. Okay, 3-inch. As I say, that guy extend one row below, but with no extension on top. I can only extend both way. I don't have the option to extend one way, one at the bottom only. So I add 3 rows, but here you see here there's a heating here. But anyway, I try it this way. Okay, try this way, and now the force is 2 to 3. I believe it's 50%. 2 to 3. Okay, 2 to 3. 2 to 3. I believe match this one. 3. 50.2 keeps. I believe it match this one. 50.2, 50. Okay, so 50.2 keeps, and the shear force is 50 kilonewton. I believe it's 50 kilonewton. 80 kilonewton, sorry. 80, it's 18 kips. Okay, minus 18 here. 18 update. So you see minus 10 are 18, 50.2 kips. 1/4, I get 0.55. So it's a 250 73 to V-axis, or 250 by 58. So I had used 3 rows of bolt. Okay, but this guy here, because of this flange, they move these rows to below, but I can only extend both way. I don't have extension options of extending one way. So I finished this one. Okay, so there's 2 connections. One is 305 strong X6, 200 W200 to strong at to V-axis. Now I am to do this. It's a wraparound gusset plate. It's 42. It's WT 100 by 13.5. Drop 4-inch below. Top of steel. 30 kilonewton compression tensor. So that detail is flip upside down. It's like this. Okay. The connection it flip upside down. Okay, it free up, but anyway we do this way. Okay, so that's a wraparound gusset plate. The beams 236 and 227. Okay, the WT 100 by 13.5 should be all right. So the beam is 227, 236. Okay, 236. Okay, so you see here 236, 227. Okay, so it just flip upside down. On the plan view it's like this, but it flip up. Okay, don't worry. So we'll do this right around gusset plate. All right, so now, all right, so all right, so now go to general. We have a brace connection. We choose a red plate. Okay, and you see here that's current. Okay, so that's top left. Okay, top left, top left. So top left, and the angle is 51 to vertical. This brace to vertical is 51.5 degree. Okay, 51.5, 51.5. All right, so the column size section, the column size is 250 by 58. 250 is Canadian. Okay, Canadian. 250 by 58. 50 by 58. Okay, so this beam is 236, this beam is 227. Okay, 236 vertical beam, 236. Horizontal beam is 227. All right. So that WT is 100 by 13.5. Okay, drop 4 inch. It dropped 4 inch. It dropped 4 inch. Okay, it's here. Okay, so you can see here. Drop 4 inch. Okay, this guy 4 inch, 4 inch, and the section size is 100 W100. Okay, Canadian section WT 130.5, 113.5. Okay, 113.5. So we have 2 bolts here, 3 inch. We have 2 bolts here, all 3/4 bolts, and we have weld of 1/4. The angle, what's this? The angle, what's the angle size? And here the angle, what's the angle size is 76, 9.5. Okay, so vertical beam and brace to 2 bolts instead of 1 bolt. Okay, angle size 77. What's the angle? End plate. Okay, now it's end plate. Actually we use angle. Okay, it's not end plate, we use angle, so we change to angle below. Okay, and we use 2 bolts, 76 Canadian section, 76 9.5. Okay, we copy everything and we go to horizontal again, change 1 angle below. No, 1 angle below. Okay, 2 bolts, and the size is 76 9.5 Canadian, 76 9.5. Okay, and copy everything. So we set up this angle. Okay, now this angle and the weld. Okay, so it's a bolt on the vertical leg and there's a weld to gusset on the horizontal leg by 1/4. Okay, it's weld by 1/4. It's bolt. Okay, so we go to horizontal to gusset is weld. Okay, by 1/4. Update. It's 1/4, and go to vertical beam. Again, to gusset is welded by 1/4. Okay, update. We are done. Okay, so now we have this distance. Okay, this gap, and that's this one is 1.5. But what's the to the edge of the column? I don't know. 1 inch. And let's say there's no dimension here. Let's say this cut out, okay, to the edge of the flange is 2 inch, and this cut out line to the edge of this one is 1 inch to the tip of the flange. Okay, so now we'll go to gusset plate. You see this one? Okay, let's cut out to the out face of flange. Okay, cut out to the out face is 2 inch. There's no dimension here. I assume it's 2 inch. Okay, so that guy is 2 inch. Okay, now it's 2 inch. All right, So see the highlight, 2 inch here. That cut out to the tip is 1.625. I assuming 1.625. See the highlight? See the highlight here? I assume it's 1 inch. Okay, there's no dimension here. 1 inch now. Okay, that's 2 inch now. So we pretty much match this one. It's flat here, and slightly we shorten this one to 1 inch. Okay, it's almost flat here, and the gusset plate thickness is what, ½ inch. Okay, and ½ inch. We go to WT. This gauge is not right. We copy everything. This gauge. Alright. Now it's 3 inch. See here? 3 inch. Alright. 1/2. That's ½ inch extension. Okay. ½ inch extension. 1.5. Okay. 1.5. Alright, so this one should be 1.5. 1.5. Update. And this one should be 1.5. Update. Gusset plate thickness is gusset plate is ½ inch. Okay, that one gusset plate is ½ inch thick. Alright, so we are pretty much there, and the force is 30 kilonewton. Okay, 30 kilonewton force, tensile compression. See here, C and T, 30 kilonewton. It's very little. Okay, so it's 30 kilonewton. Actually, it's 6.8. 6.8 design load minus 6.8 plus 6.8. It's compression and tensile. All right, so 0.25. We finished this. We finished this right around gusset. Okay, one more thing. Okay, yeah, one more thing. Okay, we finished this right around gusset plate. Sketch. Where's sketch? Okay, so nice view. Okay, look at this. Okay, this right around gusset plate. It's a quick angle at the bottom. Two bolts. I finished this right around gusset plate, remote section, and the side view. All right, the side view of this one. So continue with next one. 442 we are done. So 442 we finish one shear connection to strong axis of column, shear connection to weak axis column. We finished the right around gusset plate. So on the plan view, we finished this shear, and right around gusset plate. Now we can go to 439 at the elevation 301. Okay, 439 is this one. Okay, so that's column strong axis with vertical brace with this beam. Okay, both sides. I just do one side, the other side is similar. All right, so again, as I say, this continuous member, we call it column, and with this column 439. Okay, a strong axis. All right, so with this column, you see this pass-through force. We do the vertical brace of this one. So on the elevation view, okay, we do vertical brace of one side, right side, and left side separately. So we do the vertical brace on this one, assuming there's no left side. Okay, we do the vertical brace of left side, assuming there's no right side. The connection relationship between the left and right is this pass-through force. All right, so we do it separately, left and right. The relationship between left and right is this pass-through force. Okay, so we do this one first. The column 250 by 58, the beam is 236. That's welded double angle brace connection. All right, so this brace to vertical line angle is 47.5. Okay, so I would move this one out. Okay, now we're stuck. It's this connection. All right, 236, 258, 250 by 58. That's double angle connection, 340 C&T. Okay, it's a huge. Okay, so now I go to general. I go to vertical brace. All right, so the column is at the left. Okay, and it's the column it's to Gusset connect to column flange strong axis. Okay, so the angle 47.5 to vertical, and the section, no, I go to this one. It's double angle 127.89 half inch. Okay, 127. Okay, so it's a double angle vertical, and that's bolted. Okay, now our case is welded 1/4 and 6-inch weld. Okay, so we change this one bolted to welded. Okay, now I change to welded, and the size is 127.89 Canadian section. 127 is a long lap vertical. Okay, 127.89 half inch. 179 half inch. Okay, and the weld line is 6-inch. 6-inch 1/4, and the gauge, it didn't show the gauge, but I will use default. Okay, whatever the gauge is 2.5. 2.5 here, I copy, so 2.5. Appears to be very short. Appears to be very short. I assume it's 2-inch. Okay, 2-inch and 1/4. So 2-inch gauge, 1/4, 6-inch. Okay, and the bolt here is 2.5, 3.5, 3.5, 3 rows, 2 rows, 236. Okay, so now section, the beam had to be 236, 236, 2 rows. Now is 2 rows extend 1. Okay, 2 rows extend 1 with a stiffener plate here, so I can only extend both. All right, so I will consider, the program will consider this row and this row belongs to beam to column. Okay, so I'll go to see here, I will add rows here, beam to column, copy, and the now here's 2.5, 3.5, 2.5. Okay, so this one is 2.5, and it's 2 rows. Okay, so 2 rows, 2.5, 2.5, 3.5. That one is 3.5, 3.5, and it's 2.5 here. Okay, so that plate thickness, the end plate thickness is 15.8, gauge 3.5. Okay, 15.8, 15.8.625, 58, gauge 3.5. Okay, 3.5, update. So it's 58, plate 3.5, 3.5, 2.5, 2.5, and the 1/4, it's 5/16 now. What's the weld? 1/4, 5/16. I can use 1/4. Okay, then there's 2 more rows. I have this one, there's 2 rows of bolts, and I believe it's 3.5, 1.5. Alright, so now we have this one, Gusset to column, 2 rows, and the 3.5, and 2 rows of bolts. I use 3 inch, 1.5 here, half here, update. Alright, so now that weld line is 1/4, that weld line is 5/16. Weld size is 1/4, 5/16, and the clearance is 4 3/4. See here, the tip to the end plate is 4 3/4, the clearance. So Gusset plate, here's 1 inch. We have to 4 3/4, but it appears the clearance is to the horizontal. It's not the vertical. But anyway, that's because my clearance, for my case, my clearance to horizontal govern. Okay, it's not to the vertical govern. So I can only clear 4 3/4 to horizontal. I don't know what's the horizontal clearance, but it dimension is to vertical 4 3/4. Never mind. It appears a little bit more, a little bit short. Since my clearance is to horizontal, I use 4 inch. See, it's a little bit too much for 4 3/4. I use let's say 4 inch. Okay, but anyway, the Gusset plate thickness, Gusset plate is 1/2 inch. Alright, 1/2 inch, and that one is 1 inch edge, 1 inch extension. My case is 1 inch. Yeah, 1 inch, 1 inch. See here, 1 inch. Gusset plate is 1/2 inch, 1/2 inch. It's okay. So Gusset to being weld is 5/16, and go to straight. Okay, 5/16, and it seems there's a stiffener plate here. Stiffener plate here. So beam to column first. Beam to column. Stiffener plate. We have stiffener plate here. All right. So that one is go straight. It's 5/16. Go straight vertically. So Gusset to beam. I copy this guy, so go straight 5 and 16. All right, direct weld. Okay, now again, the column size is 250 by 58. It seems my column size is not right. 250 by 58. Okay, 250 by 58. 250 by 58. All right. So now it appears okay. Now this one is not right. Gusset beam. Copy again. Go to vertical. Okay. So now it appears front view. We all done. So, okay with this one. Now go to the force. That's a pass-through force. All right. 250 kilonewton transfer force or whatever you call. 250 kilonewton. It's very big. Okay. It's 56.3. Okay. Now design load. So that's the transfer force. 56.3. 56.3. The transfer force always 56.3. Always key in the positive value, which represent the tensile transfer force. Okay, negative value represent the compressive transfer force. But normally, as a connection engineer, if no ideas, they mark normally when they mark these 250. It appears to be tensile here. So to be conservative, always assuming it's tensile transfer force 250 kilonewton, which is 56.3, and the shear force is half of it, 128. I believe is 128. 128. Okay, 128. And to A, so half of section 28.8. I believe we have 29 here. Okay, same thing. So V-axis we don't have it, and 29 or 28.8, 28.8 shear force strong axis, 28.8. All right. So now the tensile force. Tensile compression, okay, 340 kilonewton, 340 is 76.5. okay, so it's tensile 76.5, no, tensile 76.5 and compression 76.5. Update. Okay, so now we have two cases. One is tensile 76. See this one? Okay, tensile 76.5 and compression. See here, 76.5 is shear, 28 strong axis shear, 28.8, 28.8. There's no V-axis shear. Okay, that's being the column. There's a transfer force of 56.3. We always assume both cases tensile. We get 1.01 ratio, which is good, slightly over. Okay, let's see which part. It's being the column. Okay, being the column. So go to being the column, see which part slightly over, 1.01. Okay, so it's column flange local bending. Okay, so click this one, column flange local bending. So I believe you add stiffener plate or what, I don't know, and being the column, you add stiffener plate or what, I don't know if you have option of that. Okay, general, if an option of that or not, I have no idea. All right, so I probably have, but to save time, so we finished this one. Weld double angle LLV weld to gusset plate, and this beams we finished this one with this guy. of this guy's sketch. Print this one. Nice sketch. We have these 6-inch okay, weld with more sections and the front view. Okay, that's this one. So probably I can do this one on the left side. Okay, and it's bolted instead of welded. Okay, so I don't know. Okay, so we do the right side, now we do the left side. Okay, now instead of welded, we do the bolted now. Okay, apparently the section is the same, 1 to 7, 89. The force is the same. Gusset plate thickness is the same. The beam is slightly different, 236, 246. The angle is the same, 47.5. Most of it is the same, except, okay, now we colon at the right. Now that one is welded. Now we change to bolted. Okay, and the gauge is 3-inch, 3 rows of bolt. 3 rows of bolt, gauge is 3-inch. Okay, copy. Now it's 2.5. I don't know why they want 3-inch. 3 rows of bolts. All right, and the angle is the same. Okay. All right, 2 rows go vertical. Have column size is 246. No, beam size. Section 246. Okay, so that go vertical, 1/2 inch go vertical. Gusset to beam. I copy this one, go vertical. And the that's it. Okay, same force, same transfer force. That is slightly more the shear force. Okay, compared to 1 to 8, I believe is this guy 34. Okay, 234 instead of 28. 34 update. Okay, slightly over, same location, I believe. So we now go to this. Instead of welded, we have bolted. All right, so now show you the sketch print. Okay, now we have bolted and column on the right. Okay, we more section. That's it. So we finish this one. Now I have V-axis. Okay, V-axis. I will do this. What I say is VX 439. Okay, now we go to elevation 305. We have strong axis here, the column strongs. Now go to elevation 305 is V-axis. 305 here. We have V-axis here, and we have knee brace here. We have vertical brace here, 236. Column connection number is 439. So 439, no, 439 here. So that guy, V-axis. Okay. So I will do a very quick, I don't know, knee brace. I'll probably do this one for you too. It's 2-inch. See here, 2-inch clearance to the web. So the angle is 35.6. So I do this. Okay, it's called 439. Okay, and it's called 439. So the angle is 35.6. Okay, so close this one. So general colon at that 35.6, 35.6, and there's no additional bolt, but just weld to the flange. The end plate weld to flange. There's no additional rows of bolt. There's 2 rows. I assume it's 3.5. Okay. Okay, 2 rows of bolt. So now go to beam column. We go to this one, and the 2 rows of bolt, 3.5, 1/4, 1/4, and there are 3 rows of bolt, 258, VX6, 236, VX6, so it's strong X6. I go to VX6, connect to column web, 236 section, 236. And how many rows of bolts? How many rows of bolts? 1, 2, 3, and 3.5, 2.5, 1.5. 3 rows of bolt. What? Why? 3 rows Gusset column. 3 rows of bolts. Copy. Gauge should be 3.5, I believe. Spacing 3.5, 1.5. That's 2.5, I believe. Update all. Okay, 2.5, 3.5, 1.5, and the well is 1/4, 1/4. Go straight, 1-inch extension. Okay, and the well is 1/4, and the clearance is 2-inch clearance. Okay, it's 2.5. Okay, I'll do this. 102. Double angle 102.76, 7.9. 102 and 2-inch clearance. Okay. So double angle 102. No, double angle 102 on there. 102.76, 7.9. 3 rows of bolts. Copy everything. Copy everything. 2.5 gauge. I don't like it, but actually it's 2.5 gauge. Extension 1-inch. Clearance 2-inch. Okay. So Gusset plate clearance 4 inches. 2-inch. Extension 1-inch. Okay, see, you see here clearance is to the web or to the end plate, in internal end plate. Okay, clearance edge toe to the internal web. Now my clearance is to the flange. Okay, flange line. So I change to -2. It will clear to the web. Okay. So now appears the brace go in, but appear the governing case is to horizontal. But anyway, it moving. Okay, 1-inch extension, and go to Gusset to beam. I copy this one. Go to straight. Okay, and the well is 1/4, 1/4. So now here well is 1/4. Update. 1/4, and Gusset plate thickness is 1/2 inch, I believe. Let me check. Gusset plate thickness is 1/2 inch. There's a clip here, 1/2 inch, correct. And the end plate thickness is 1/2 inch, gauge 3.5, 1/2 inch thick. End plate thickness is Okay, gusset column, 1/2 inch. Okay, and the gauge is 3.5. There's nothing wrong here. So we're pretty much done. So now the force is 190 kilonewton tensile compression. The shear force is half of it. Okay, there's no transfer force. Okay, so 190 kilonewton, 190 kilonewton is 42.8 minus 42.8 plus 42.8, and the shear is 29. Shear is 29, strong axis shear. There's no V axis. There's no transfer force. Update 0.67. Okay. So look at these connections. Again, we do right assuming there's no left. We do left assuming there's no right. And the relationship between these two is transfer force, but there's no transfer force here. We do it separately, left and right. Okay. So we have the right side of this double angle bolted connection. It's connected to the V axis of 250 by 58. 250 by 58. So that's the connection. Okay. That's a nice sketch of this one. We do the left. Now we do the right side with knee brace. Again, the column. Okay, 3 bolts. It's equal angle here. Now the angle is 44.3. Okay, to vertical 44.3. So general column at the right. Angle is 44.3. 44.3. The angle size. Okay, actually it's not vertical brace, it's knee brace, column at the right, and the angle is 44.3, and the column the right to column web, and the brace section is 76 equal angle now, 76 by 6.4. Okay, copy everything. 3 rows of bolts, 1/2 3 inch. Three inch. It's 1.5 and half. 3 inch. So now the clearance is to the flange now. Okay, 1 inch to the flange line. It's not to the web. So clearance 1 inch. So I have to go to here, change. Now it's 2 inch to the web. Now I want to clearance to the flange line. I will change this one to 1. Okay, now so 1 inch clearance to the flange edge, and the see here, I don't know. It appears this line, there's not much extension here. It goes down on flat. Okay, I don't know what's the distance of this one. Just assume a number. All right. So now 1 inch clearance, gusset to column. Now it's copy. If copy is flat, as I go slightly less, 12 inch, because I don't know. Here's 10 inch. Apparently it's not that much. I use 1 inch here. Okay, it's more like this one now, and it's 1/4 welt. one quarter, and the gusset plate is 1/2 inch. Okay, 3 rows of bolt, one quarter, gusset plate is 1/2 inch. Okay, 3 rows of bolts, and the gauge is 1 3/4, 2L, 1 3/4. Okay, gauge. Okay, pretty much the section is there. And the connection force is 120 kilonewton. Okay, so 120. Move this out. 120 kilonewton. 120 kilonewton. It's 27. Okay, so design load is 27. Okay, so tensile compression 27. Update 0.36. Okay, so that's done. And this left side knee brace. Okay, double angle and knee brace. So my sketch is print left side. Okay, knee brace. Okay, so I'm done. So now 39 is done. Now I go to the last two. Elevation 301. Okay, 301 70, I believe. I go to this chevron brace here, 470, 75. Right, I'll do this. Okay, this welded chevron brace, 470. So it's this guy. So it's 12789 1/2 inch. The beam is 236 chevron brace. Okay, beam is 236. 12789. Okay, vertical chevron brace. So the angle is 42.5 to horizontal. So to vertical it's 47.5. All right, I only use vertical line. Angle between brace and the vertical line is 47.5. All right, so chevron brace, general knee brace, change to chevron brace, and the right side. So it's double angle. It's double angle 12789 1/2 inch, 47.5, 47.5 angle, 47.5, and it's welded. Okay, now it's bolted. It's welded. Okay, so the size is 12789. It's a long lap vertical. 12789 and 1/2 inch. Okay, so the weld line is 6 inch, 1/4, 1 inch extension. 6 inch gauge is, there is no gauge dimension. I use default. Okay, I use default 1/4, 6 inch. Okay, and I think that's it. Okay, 6 inch, and clearance is 1 inch extension. The gusset plate 1 inch, clearance is 1 inch. Gusset beam, copy, and it's 5/16. Weld size 5/16. 5/16. Update. And so I finished this copy. Right side I copy everything to the left. All right, and that one, the toe is on top. No, the flange is on top. I go to change to left. I have to flip this one and copy everything. So now, and we have stiffener plate. Okay, Gusset pin. I don't know if general. We have stiffener plate. Yeah, that must be somewhere. Gusset pin. Allow me to add stiffener plate. There must be somewhere. Brace casual brace and top left flange. There's no way I can add stiffener plate. I think Chevron brace being at top. Well, there's no option of adding stiffener plate. But anyway, it seems there's no option. Okay, 340 kilonewton. 340 kilonewton is 76.5 kips. 76.5. So 76.5 minus 76.5 or minus 76.5 positive 0.5. There's no transfer force. Alright, these Chevron bracelets always tensile compression tensile, otherwise it won't be bearings. Alright, update all. 76.44. So we are done with this Chevron brace. Okay, welded Chevron brace, double angle welded 6-inch. Now the sketch is here. Right, double angle welded Chevron brace 5/16. That's it. So let's last one 470, this guy. All right, so we go to plan view 10305. We have this one 470. That's a horizontal brace. I go to this plan view 470. Okay, that's a horizontal brace, but it's a 3WT. Okay, the middle one is WT 15526. That guy is what's the size? What's the size of this one? 15526. All of them. Let's see. 15526, but it flips upside down, right? So that one, it flipped down. Connection, I don't know why they flip down. Okay, we'll do this. It's a 3WT connect to one Gusset plate. 3WT. All WT size WT 15526, WT 15526, WT 15526. connect to one gusset plate. The beam is V-axis is 236. Okay, horizontal brace 236. We'll do this. All right. So remember the angle is 37.6. 37.6. We'll do this. All right. So now general is there's no there's no beam here. There's beam tends to be a chord, a horizontal chord, something like that. So we choose this one. Okay. Go to vertical brace. Okay, so see this one. So now this case, for our case, see the middle one is a WT. For our case, it's more like this. Horizontal member connect to gusset plate. It's not like this. Horizontal member connect to column. There's no such case. It's this one. Horizontal member connect to gusset plate. Okay. So we choose this one to gusset plate, and it's a WT bolted, but our WT is below the gusset plate. Okay, so WT, and that one will change to WT2. WT shape. WT is behind gusset, and it's bolted. Okay. So now so all WT is 15526, and that one is being on top 236 to V-axis. Okay, to column and being on top, column at top. Okay, and the 236 section, 236 and the channel is 236. The angle is 37.6, 37.6, and the size is 15526 and 2 rows. Okay, 155 26, 2 rows of bolt. Copy everything. It appears the gauge is 3.5, 3 inch, 1.5. The gauge 3.5, 1.5, 1.5. It appears like that. Okay. All right. So gusset the beam, gusset the column, copy it, go to straight. Okay. And the it appears this one is 1/4, and this one is 3 rows of bolt. Okay, that one is 1/4. Update. Okay, horizontal strut, 3 rows of bolt. The gauge, both spacing vertical. See what's that? That's 3.5. 3 inch, 1.5, 1.5. Update. And the alright, it seems we are there, almost there. 1 inch gusset plate. The gap, the clearance is 1 inch. So now we have left and right. We copy everything from right to left, and we gusset the column. We copy this one, Alright, so we're done. Have extend more. It's a 5 inch spacing instead of 3 inch. Okay, horizontal strut. It's 5 inch. It's almost touching again. One half. It's almost touching. I don't like 5 inch. We change it to 4.5. Okay, slightly clearance to that. Alright. Okay, that size is not right. So it's 155 Canadian section. 155 26. Three and a half. Okay. Alright, so now it's 140 kilonewton, 110, 110. That guy is 140. 110, 110, 110. 24.8. Design mode. What's that? 24.8. 24.8 minus 24.8. That one is minus 24.8. Positive 24.8. And that one is 140. 140. 140. 31.5. There's no shear at this moment. 31.5. 31.5 and minus 31.5. Update 0.36. Okay. So we have this bolted 3 WT connect to one gusset plate, and the gusset plate connect to the VX6F W236, and we have this one with ratio 0.35. It's done. Sketch. Print. See, nice sketch. Okay, nice sketch. So we're done with this one. So this one conclude the demo 1 part 3. See you next time on the demo 1 part 4. Bye bye.